All right. So today I want to welcome you to the introduction.
Yes,
and we are going to be trying to look at the firewalls and trying to understand what are firewalls. I know we have already talked about them briefly, so we shall be going through some of those things very, very fast, because now this word is not alien to us, and we have looked at it in the previous few slides. So during data communication, insecure factors may cause information leakage or incomplete information, or even unavailable information. Therefore, firewalls are required during network deployment. This course introduces the history, features, typical networking models, application scenarios, and technical specifications of Huawei firewalls, and also how other firewalls operate and work. If your microphone is not muted, like Jonathan Okelo, please go ahead with your microphone. There's a quacking noise from your background. Please keep all your microphones muted. Or else I will ask my co-hosts to put you in the waiting room until you learn how to mute your microphones. So upon completion of this course, you will be able to understand the basic concepts of firewall, understand firewall security policies, and also have a good command of firewall security policy configuration. So let us look at the firewall overview and try to understand what firewalls are. Originally, we said in the previous course that firewalls were built, was a wall that was built between houses, and basically to prevent the spreading of fire. They built them to spread the spreading of fire between those houses. And this technology was very important security technology, that even if someone started a fire somewhere, it could not spread across the city, because they built a firewall, and this firewall would help to prevent fire from spreading. So also in this course, we want to discuss hardware firewalls. And hardware firewalls basically integrate security technologies to protect private networks or computers from, external networks. And to do this, they use some kind of dedicated hardware structure, high-speed CPUs, embedded operating system, and they also support high-speed interface, or LANs, what you're calling local area network interfaces. Hardware firewalls are independent of operating systems such as, NT, AXI, Sun OS, and etc. And of course, they're also independent of computers. Hardware firewalls are used to solve network security problems in a centralized manner. They're applicable to various scenarios, and they provide efficient filtering, and they also provide security features such as access control, who is allowed to access what, when are they allowed to access what. Also identity authentication, making sure who is exactly accessing our resources. Are they allowed to access our resources? And should we even give that particular identity permission to access those resources? And then, of course, data encryption, making sure that the data that is sent from one end to another is encrypted through technologies like VPN. We shall be looking at VPN in the next coming chapter. And network address translation, I think, which is the next slide. So users can configure security policies based on their network environments or needs to prevent unauthorized access, and also to protect their networks from unauthorized access or manipulation. Today, a modern firewall should not just be an entrance barrier on our networks, but it should be access control points of our networks. It is controlling whoever is accessing our data, and all data flows entering and leaving the network should always pass through the firewall that serves as the gateway for incoming or outgoing information. Therefore, a firewall not only protects the security of an intranet on the internet, but also it protects the security of our hosts on the internet, and all computers in the same security zone configured on our firewall are considered to be in the trust zone, or they are considered to be trustworthy. And communication between them are not affected by the firewall, but however, communications that are coming from different networks, they must follow the policies that are configured on our firewall. Just like you can see in this illustration here, we have our firewall, and our firewall here is helping us to, protect our our intranet, the local area network. Probably it is our office, or probably it's our data center, and we have a firewall that we have installed here to make sure that it helps us protect us from the internet. When the user is accessing, we can now be able to give access, and give access control to whoever is accessing our network from an external network. So firewalls use logical area filtering. They help us to hide our internal infrastructure, and also they give us security awareness, and they also have the capability of proactive defense against attacks. So can the traffic that does not pass through a firewall be protected? That is the question that we have been asking ourselves. So firewalls are classified into different two types, and according to access control modes. There's a classified into packet filtering firewalls, proxy firewalls, and stateful inspection firewalls. Now, for over 3 generations, firewalls have been developed, and their classification methods, vary from time to time, and depending on who is explaining the classification. It can be either classified either hardware or software firewalls, or even by form, whether they are standalone firewalls or network firewalls. So, but the most common kind of classification is the way they are going to deal with the packets. Yeah, are they going to do packet filtering, or are they going to is it going to be a proxy firewall or a stateful inspection? And we're going to look at some of these things later on in detail. So let us first look at firewall classification, which is the packet filtering firewall classification. So packet filtering, before we even look at the illustration, checks each packet at the network layer and forwards or discards the packet based on the configured security policies. Now, you as a security engineer, you configure policies and say, oh, now you firewall, help me. When this packet is coming from this kind of machine, please block it. When it's coming from this website, please do not allow it. If it is a video type of packet, block. If it is maybe coming from YouTube, block. And if it's coming from Facebook, allow, etc, etc, etc. So the firewall is going to also filter packet by packet, right? That is going to be coming through, and it's going to check the network layer, and then either forward or discard based on the rules that you have configured you as an engineer. And the basic principle of packet filtering is just to configure what we are calling the access control lists. So when you configure the access control list to filter the data packets, you also configure them based on either the source or destination IP address, or the source and destination port number, or IP identifier, or even packet transmission direction in a data packet. And data filtering packets, firewall is they are usually easy to design and easy to implement, and they are also cost effective. Okay, but the challenge with packet filtering firewalls, it is hard for them to deal with multi-channel protocols, like example FTP. It is usually hard to deal with them. And also by using ACL, the access control list, remember static access control list rules cannot meet dynamic security requirements. Like some of those packets that are dynamic and they keep changing, if you have configured the source number and destination port number, and then a given application randomly assigns a source port number, then we are already seeing problems arising from this kind of access control rule. And of course, packet filtering has another disadvantage, that it does not check session status to analyze our data. For it, it is concerning with whatever packet comes through, it's going to filter. That means if it is filtering every packet that is coming through, there's a lot of complexity, a lot of increase use of resources, and also the filtering performance decreases with time as many requests coming and out of our server. So basically, we have our TCP layer sends the packet, our IP layer, which is going to be checked to the data link layer from our computer. So it was sent, and when sending the packet, the firewall is going to check the network layer. It's going to look at the IP layer, mostly important, the TCP layer, to check and see the packet headers and see is this destination port number and what allowed or denied. And depending on that rule, it will then now choose either to forward it or to discard it. So it is unable to associate data packets and unable to adapt to multi-channel protocols like FTP, okay, like FTP, and does not check the application layer data here. So if someone has written malicious code or something for packet filtering, it does not check the application layer. For it just concerns itself with the TCP layer and the IP layer and with the rules, and then it is able to forward the packets to the intended destination. That is packet filtering. So by proxy, like you hear the word proxy, he's working like an agent on behalf of someone, right? So proxy applies to application layer of the network, and the proxy checks the services directly transmitted between the intranet and the internet users. After the request passes through the security policy check, the firewall has to establish a connection with real server on behalf of the internet users, and it's going to forward the internet user request and sends response packets returned by the real server to the internet user. So this proxy firewall here, it can completely control the exchange of the network information and session information, achieving high security. But now because it is going to deal with all the packets coming through on behalf of the other, then it's going to also have slow processing, and it's also most times difficult to upgrade, because now each application layer proxy must be developed for each protocol. Okay, must be developed for each protocol. Let me see. Okay. Please, my co-host, when you see someone is not muted, kindly help me mute them so I don't have to change my area of focus to come into Zoom and mute people. That's one of the reasons why you are co-hosts. All right, so the application layer must be developed for each protocol, and the development period is long, and the upgrade sometimes also is difficult. But what happens is PC will send, okay, excuse me, agent, I want to be able to access some files on the server. It's like, okay, you want to access which files? I want to access that. And this guy will say, excuse me, he's the one who is accessing. I want to access his files. Do you permit this guy to access them? Oh, yes, I do. Then this guy will get the result. Okay, you can now access the files on the server. So, oh, I can access them. Okay, what do you want exactly to access? Then this guy accesses, it's sent through this guy, then this guy also sends back. So it's going to send a connection request, and after sending the connection request, it's going to, between itself and the intranet server, perform security check on the request to see if the check fails. Then the connection is going to be blocked by the server, and if the check is successful, then the connection on the server is going to be set up. And after it is set up,
excuse me, Mr. Sandy. Hello.
Yes, please.
You're talking too fast. Could you go slowly? You're talking way too fast.
I'm talking way too fast. Okay, let me try to be a bit slow, but we have a lot to cover, and I beg that after the course, you can go through some of these materials. But basically, I'm just going through now why I'm going fast. I'm just going through the process, how the proxy server works.
Okay, thank you.
All right. So, yes, please.
As you intend on going slow, you should also remember that we wasted 46 minutes from the time that we on just questions. Yeah, please.
True. All right, so it's going to send a connection request, and this guy is going to perform the security check. After performing the security check, it's going to either block or deny depending on if the security check is successful or it fails. If it fails, then it will block. And if it is successful, then the connection to the server is going to be set up, and this proxy will now notify this guy that, okay, the connection with the client has been checked, has been set up, and now we can be able to communicate accordingly. So now say hosts, this client PC will send a packet to the firewall, As you can see, it doesn't send the packet to the server, but it sends the packet to the firewall. Then the firewall will get the packet and send the packet on behalf of PCA to the server. When also the server responds, it will respond and send the packet to the firewall. It doesn't send it directly to the PC. And then also the firewall will go ahead and receive the packet. As you can see now, this one is doing all the work. Receive, send on behalf, receive, send on behalf. That is, slow processing, and also sometimes it is difficult for engineers to upgrade this kind of classification. Now the other one is what we're calling stateful inspection firewall classification. And for it, it is concerning so much with session headers, and we're going to look at them and try to understand what it does. But it does security check and session information recording. It has high fast processing of subsequent packets, and the keyword is subsequent packets and high security. Stateful inspection of the packet filtering technology. Packets are filtered based on the connection status. They're filtered based on the connection status, and with each packet treated as an independent unit and in the historical association of packets considered. So all data flows based on reliable connections, that is TCP flows, are processed in 3 phases. And we know that we have a client request. We know the server has to respond. And then lastly, the client responds. Who remembers that? We said it is a 3-way handshake, the one we looked at in the previous classes, right? So this indicates that each data packet does not exist independently, but it is closely related to preceding and subsequent packets. So based on the status association, the stateful inspection technology is developed. So what it does, when a client A establishes and starts sending a packet, remember packets, it is a user data, and user data is broken down into different packets which are sent, because remember it cannot send that big block of data at the same time. So data is sent in form of packets on our network. We all agree. So what happens when packet 1, 2, 3, 4 comes? This firewall is going to first check the first packet, and it's going to establish whether there's connection with the server, and if the server permits this client A to be able to send the packet. After establishing, what will happen when other packets just come through? It just checks the status of the session header or the session information, and if they are part of the same group of packets, then it does not do processing for the other subsequent packets. They just pass through, because it's like you when you're going to a place somewhere and you are going as your organization, and you go there and you get into your vehicle. I don't remember how they drove vehicles. And you get into your vehicle and you get to the gate. Usually they'll just come and talk to some of them. I know some people ask you to move out, but some places they just come talk to the driver. Oh, we are from Makerere and we had come for this summit. Oh, okay. Yeah, how many are you? We are 41. You're 41. Do you have your ID? Yes, I have my ID. You have invitations. The invitation is here. And then they will let in the bus to go through the gate. They have not checked everyone inside the gate. So they are doing stateful kind of inspection. So as long as all these guys' status, they are seated in this bus of Makerere and they are accessing the premise, then they're not going to go ahead and process, as opposed to everyone coming one by one. And this is either proxy or packet filtering, where you come one by one and they have to check everyone who goes in. The process here is slower in packet filtering and also in proxy. Let's say if you have sent someone and someone has to just come and talk on your behalf. Okay, I've come to attend. Did he have the permit? Yes, he has the permit to attend. Okay, you can tell him to come and then he can send, and then so the process becomes a bit longer. So here with a stateful inspection, basically it looks at the first packet, establish the connection with the server, and as long as this packet is permitted on the system, then it will go ahead and permit or allow the packets to be moved from the subsequent packets to move and also to be transformed on the server. So it has the advantages of high security, since the connection status list is dynamically managed, and every time the packets come through, it dynamically keeps on updating its session information. And also the firewall uses real-time connection status monitoring technology to identify connection status. So that means that we have advanced kind of security. And also it has outstanding performance for processing subsequent packets, because when checking the packets, like I've told you, based on the access control list, the stateful inspection firewall records the connection status of the data flows, and the subsequent packets in the data flows do not need to be checked based on the access control list. Instead, the firewall just checks the connection status records of the newly received packets according to the session table, and after the check is passed, the connection status record is refreshed to avoid repeatedly checking the data packets with the same connection status. So what will happen? It will just go ahead and check the connection status, and then it will either see if the status is incorrect, it will discard the packets. If the status is correct, it will go ahead and allow the packets to go through, and also the subsequent packets will not be processed one by one. It will just allow the subsequent packets to go through. So the security policy check and session information recording. Now we want to look at firewall modes. We can have different modes. So mode 1, firewall only forwards packets and does not do any kind of routing. And this mode 1 works at layer 2. The two service network interconnected by a firewall must be in the same network segment. .10.10.02, they must be in the same network segment, and for it works at layer 2, and it does not perform any kind of routing. And in this mode, basically both the upstream and downstream interfaces of our firewall, they work at layer 2, and they even most times here they do not need to be configured. These interfaces on our firewall, they don't need to be configured with an IP address. Sorry about that. And then when it comes to mode 2, here of our firewall, it works at layer 3, and the firewall here is located between intranet and someone's microphone. Is located between intranet and the internet, and the upstream and downstream service interfaces of the firewall work at layer 3 and must be configured with IP addresses in different network segments, and the firewall performs routing on the intranet. So that means already that the firewall, since it's working at layer 3, it has some extra more features, security features like network address transmission is added onto it, and that means that also our network topology now needs to be modified if we want to change anything. So that means they are going to act as our gateways, and as you can see in the interfaces, we need to be able to configure IP addresses. As you can see, these interfaces have IP addresses. So that is the two different modes. To pick out from this slide, the two networking modes, the first mode works at layer 2. This guy does not need to have an IP address. All it does is forwards the packets as they come through. Here, works at layer 3, has extra features like NAT, and also works at layer 3 routing. So let us look at the principle of firewall forwarding. As a network security protection mechanism, packets filtering mainly control the forwarding of various traffic on the network. And a traditional kind of a firewall obtains the header information, this one bearing our quintuple things. Who remembers the quintuple? Anyone to tell me? What are the 5 things that make up our quintuple? We have 1, 2, 3.
Mic check.
4. Yes, go ahead. 5. Go ahead.
We have
source IP address.
We have source IP address, very good.
Destination IP.
Destination IP, very good.
Protocol.
We have protocol used.
Source port, destination port.
Source port and destination port. Those are the 5 things that make up our Quinta. So this packet filtering firewall will obtain such kind of information from our packet to be forwarded. And it's going to match the predefined packet filtering rule that you have configured. And if it is protocol, please do not allow any ping packets to go through my firewall, and then it will not allow. And it's going to forward or discard the packets according to the matching result that you set in your firewall. So as a packet filtering firewall matches packets with packet filtering rules one by one and checks the packets, also the forwarding efficiency is low, because remember now it's checking one by one, allow, one by one, allow, one by one, allow. That's why currently to date, many of the firewalls, almost all the firewalls usually use what we are calling the stateful inspection mechanism to check the first packet of each connection. And if the first packet passes the check, then the firewall creates a session and directly forwards the subsequent packets according to the session. Okay, so when receiving a packet, the firewall is going to obtain the header, compares the header with a specific rules, and decides to forward or discard the packet. The core technique of packet filtering is the access control lists. So we have our intranet here. We have also someone who wants to access, things from the branch. And we have our headquarters here. So here we have our firewall, and it's going to help us either, if the packets are coming from our IP, from our headquarters, please go ahead and allow them to connect through the internet and access our branch, or the branch to access the, resources from our, headquarters. But if the IP packets are coming from an unauthorized user, or the user we don't know, let's say users from the internet, please do not allow and kindly discard either traffic from our headquarters going to unauthorized, IP addresses. Kindly go ahead and block those packets. So let us look at what we are calling a security policy. What comes to your mind? Someone to say mic check and tell me what a policy means to them in your layman language.
Mic check.
Go ahead.
For me, I think they're like rules.
They're like rules.
Mic check.
Yes, please.
They are standard guidelines.
Standard
Set of
Mic check.
Mic.
Yes, please.
Policies, it can be guidelines. Someone has said it already.
Okay, can
Mic
be
check.
Mic check. These are the standard procedures that are to be followed when you are doing a process.
standard procedures to be followed when
I would say regulation.
We are doing a certain,
or like regulations. Okay, thank you. All right, thank you all. Thank you all. So let us try and also define security policies as far as security or cyber security is concerned. So a security policy control traffic forwarding according to specified rules and apply integrated content security detection to traffic. The rules focus on packet filtering, and major applications, we use security policies to control network communications through the firewall, and also we use security policies not only to control traffic that is going to be coming through the firewall, but also to control who has access to the firewall. But because imagine putting up very good policies and rules, and people can't manipulate your network, but then your firewall has no protection measures and anyone can access it and change and make configurations and change things here and there. Okay, so the basic function of a firewall is to protect networks from being attacked by untrusted networks while permitting legitimate communication between two networks. And security policies checks passing data flows, and only the data flows that match the security policies are allowed to pass through. So it will look through the policies and says, this is our policy. Here we have if you're accessing these premises, please make sure you have a mask on. Please make sure you have either carried your sanitizer. And if you come and the guard stops you, that is our firewall, and asks you, excuse me, Michelle, do you have a mask? And either your answer is going to be yes or no. Do you have a sanitizer? Your answer is going to be yes or no. So depending on the policies, we have told our depending on the policies, we have told our guard, he will either permit you to go through, or he will either deny you from accessing the premise. So we'll say, according to the policy here, according to our security policy at the gate, if you don't have a mask, no entry. If you don't have a sanitizer, no entry, and he will deny you. And if you have and you match all the rules and your temperature is okay, then he will give you permission to access the premises. And also we are looking at the policies in that direction. So by using firewall policies, we can control the access rights of the intranet to the internet, and also control the access right of subnets of different security levels on the internet. Also, security policies can control. Jonathan, please mute your microphone. And I'm going to change the rules that once we put you or remove you from the meeting, you won't be able to join this meeting again. So I've changed the rules. Once we remove you, you won't be able to join this meeting again. So before you start having conversations in your background, one, make sure that your microphone is muted. So we're saying that security policies can help us to control those who have access to the firewall, also by restricting the IP addresses that can be used to log into the firewall through telnet and web UI, and also by controlling communications between our network management system, server, and firewall. So those are the major applications. This is just basically a policy mechanism and how policies work, or how you can be able to set up policies. Step one, go ahead and, I don't like that color. Step one, go ahead and the incoming data flows, passes through the firewall. We have our data coming, BBBBB is coming and it's flowing through our firewall. So what is going to happen at step two, the firewall is going to search the matching security policy, and it's going to look at the different firewall security policies that are configured. And the firewall will determine whether to allow the next operation. So it's going to check. Policy 0 says, permit subsequent operations of A. If the packet is coming from AAA, just permit. And if the policy 2 is saying, deny all subsequent operations that are coming from B. If you see B and someone is accessing from that firewall that is not from our network, please deny. And the default policy operation, of course, will always be there. And we say that the default policy as per the schedule is to block in most of the times. So the firewall now is going to process the data packets according to the rules defined in the security policy, and boom, only, as you can see, even in this illustration, only AAA has been allowed to go through our firewall. So functions of a firewall security policy, it is to filter traffic passing through the firewall according to defined rules and determine the next operation according to the keywords. So firewall interzone forwarding, we have different zones on our firewall, but also we can perform firewall interzone forwarding. We have our trust zone, and the trust zone, like we discussed in the previous chapter, is the to be protected network. To be protected network. So all the guys that are within the to be protected network, or the hosts behind the firewall, are all in the trust zone. Now, our untrust zone is that network which a firewall is protecting us from. Like, let's say the internet or external networks that you are going to be connecting to is what we're calling the untrust zone. And then inside our server here is what we are calling the local zone. And we shall be looking at some of those zones later on. So here, when no session is matched, perform the first packet filtering process. But queries, it's going to query the routing table and queries interzone packet filtering rules based on interzone and the direction to which the interface belongs. If it either belongs to untrust or to trust zone, it's going to look at the policy. What does policy 0 say? Policy 0 says packets from 192.168.168.0, we are going to permit them. Policy 1 says that deny packets from this IP address. And if packets are coming from this IP address, we're not going to allow them. And the default interzone packet firing rule is deny. Usually, most of the time, the default packet filtering rule or the default action for firewalls is to deny. And here, it's going to check the session's header, like I told you firstly. And if a session is matched, then perform the subsequent packet processing. It's not going to go through looking through the different policies for the next coming policies. And if it's not the first packet, then it's going to look up the session table and do all the entire processing. That is how that works.
Excuse me, sir.
Yes, please.
I'm sorry for interruption. You first go back to the previous slide. There is something I want to throw more light to me.
I'm on the previous slide.
Yeah. So would you throw me more light about the meaning? Because I know in firewalls, I normally meet these things, the policies, the double A and the quadruple A's on files. Mainly, I'm only finding what's the meaning. What could you throw more light about those A's? What do they mean about? Thank you.
This is just a dummy example of packets. It could have been XX, Y, Y, X, X, X. It could have been here X, X, Y, Y. This is just a dummy example to show you the kind of packets that will be allowed. That if you have allowed X to go through here, then X only will go through. And if you have denied Y, Y will not go through our packets. But worry not, we are going to look at triple A's. There's another slide about firewall user management, and we're going to look at triple A, the authentication, authorization. We're going to look at those things later on. So not in this chapter.
Thank you.
I'll beg that you be patient.
Thank you, sir.
All right. All right, so querying the session header. This is the process for querying the session header. Guys, all this material is going to be shared, but you just have to basically go through to understand some of these things. So you query the session table, and then it's going to ask itself, is the session table matched? And if it is not matched, then it's going to check whether a session table can be created, and then it's going to go ahead, look at these different entities, and then it will go and create a session and then forward the packet. And if it is already matched, then it's going to just perform the security check and update the session table, and then it will go ahead and forward the packet. So the stateful inspection mechanism, we have already looked at it. And we said for it, it doesn't do processing for subsequent packets, making processing a bit faster and easier. So when stateful inspection mechanism is enabled, a session can be created only when the first packet passes through session inspection performed by the firewall. And subsequent packets are forwarded based on that session that has been created. So when the stateful inspection mechanism is disabled, even if the first packet does not pass through the firewall, subsequent packets can trigger generation of a session as long as they pass through the firewall. So this is what you're calling stateful inspection. The session, basically what are we talking about the session? We said that they are the basis of stateful inspection because it has to first create a session table, right? And a session is created for each data flow passing through the firewall. Each data flow that is coming through, the firewall is going to create a session and update the kind of status. Are those packets permitted to go through or not? And using our quintuple, you already know what quintuple is, and you told me what it is. It's going to be used as the key value, and a dynamic session table is going to be created to ensure that the security of data flow forwarded between the zone is on top notch. So also when you're looking at the next generation firewalls, they extend the quintuple and they add on two more things. They add on what you're calling the user data, and they also add on what we are calling the application data. And these two are added on top of our quintuple to make our session have 7 things. We have our source IP, we have our source port, destination IP address, destination port, and then we have our protocol that is going to be used. We have the user who is accessing those details, and we also have the application they're using to access those resources. So this is just an example that is showing the packet that is going to match the session, and the firewall allows the packet to pass through. So it's going to look at the session header or the session table, and the session table is going to store these records. Oh, the source IP, this packet is coming from 192.168.1.1. This is the source port, and this is a destination IP address. It is going to that. And then the destination port is 23. And the protocol is TCP, and the user is ABC, and they're using the application of Telnet. Just to ask, port 23 refers to what protocol?
SSH.
Come again?
Telnet.
It refers to Telnet. So most likely, this user here is remotely logging into our firewall. So also they're going to look at this, a server client, and the session table will also be created accordingly. The source IP, when it is sending back the packets, the source IP is that. The source port is that 23. The destination IP address is this guy's IP address 192.168.1.1, and the destination port where I want to send our details is port 20,000, and that protocol we're going to use the transmission control protocol. This is the user, and they're using a Telnet application. That is a session. So this is basically a slide showing you how you can query the session table, displaying brief information about firewall session table. You just go into your firewall and say display firewall session table, and then it will be able to show you the total number of sessions that you had on your firewall, and then display detailed information about the firewall session table, and then it will go ahead and display to you. If you want to have all the details, you add the word verbose, and if you add the word verbose, then it will show you the details. So basically, this is just a snapshot of the commands which you can pass onto our command line. Remember in our firewall when you opened it last time, and then how you can access the firewall. So let us look at firewall security policies and applications. We already know that in the first packets, process, the firewall matches the packet with security policies, and the subsequent packet processes, the firewall does not really match the packet with security policy. So it will look just like I explained earlier on. It's going to look at the first packet and see no session is matched, then perform the first packet process. Look through the security policy and say, rule 1, what does it say? Rule 2, what does it say? Rule 3, 4, 5, 6, 7, 8. What is the default? The default one, like I told you before, and I remind you again, the default action is to deny. So it's going to look through those policies for the first packet, and it's going to match it with the security policies. And if it's matched with the security policies, then it will forward the packet. And if a session is already matched and the details are already there in the session table, then the subsequent packets are going to not be matched. They're going to just be forwarded, just like the bus example I illustrated to you. So this is the matching process. You just have a security policy and you have your condition. Is the face mask on? Is him immunized? Is the temperature below 37 degrees Celsius? Are they having sanitizers? Do they have an ID, etc.? So you also have different things. What is a source zone? What's a destination zone? You can have these conditions in your security policy. And in your security policy, then you have the action. The guard will ask you, okay, if you have those things, What have they told me? They told me if they have those things, I can either permit or deny, depending on what they have told me. And he also tell you the response. Because you do not have a sanitizer or you don't have a mask, I am not going to allow you to go in. Or they can tell him just, block and shut the door. They don't even have to say anything. Or he can give you a response and tell you, no, because you have no mask, you are not allowed. That's when the response will be sent. On circumstances when you don't configure response, it can choose not to send anything. When in the event that it is sent, then we can also have a profile, right? In the premises now, for example, I'll give an example here in Uganda, they allow about 30% of the, I think about 10% of the staff to be at the premises working at the currently. So they also now, after they say you have a sanitizer, you have a mask, and you're allowed to access, permitted to access the premises. But now they look at the profile. They also told them we are only letting in heads of units, or we are only letting in, essential workers. And now they look at your profile. If you're a student and you're accessing the campus, no, you're not allowed to. So definitely it will go ahead and also deny you. But if your profile, they look into your profile, if you're head of unit or if you are, essential worker, etc., and then they'll also go ahead and perform subsequent packets. Like I say, if you're antivirus or the profile is UI filtering or the profile is file blocking, it will go ahead and also update those records accordingly. So application of security policies, like I told you, we can configure policies to distinguish between employees from different departments, making network management more flexible and visualized. We can also distinguish between which applications are allowed on our network, which websites we can allow and permit on our website, which application, which kind of traffic. And you can also inspect the content security and block viruses, and also try to prevent hacker intrusions to make better protect our internal network. So this example here, we have our marketing department, and we have our, I think, I don't know, research and distribution, I don't know, retail and distribution, something like that department. And you have your intranet here on that IP address. And because it's the to be protected network, it's within the trust zone. So these guys can communicate and talk to each other without any issue. But now if they want to access, let's say, the internet or access files somewhere else or the global, an external network, then you have your different security policies configured. And you have policy 1, you have policy 2. In policy 1, here you're looking, if it's coming there could be so many other computers here, and you have any address, if it's any computer or network trying to communicate, and it's coming, it's going to any destination, let's say to you, any destination, and the user is from the marketing department, okay? And the application they are trying to access now, they're trying to access IAM, and they're trying to access games, or they could be trying to access, let's say, YouTube, right? Or they're trying to access any other application that you may feel like blocking and you have specified in your policy. Then you say the action is to deny. So these guys from marketing try to spend time on WhatsApp. They are checking the site and they're saying, oops, no, WhatsApp cannot be found, or WhatsApp is blocked on this network. You cannot access WhatsApp, because you want them to maybe, let's say, focus on their job or something, depending, or maybe even the role that they have given to you on the network from the network engineers. So also policy 2, then you have your research and distribution, department. You can configure another policy and say, when this policy comes, source address is any, and it's going to any destination, and the user is from this department, and they're trying to access any web page. Please allow them to access web pages, right? And then you give it permit. And then whenever they access www.huawei.com or whatever site they may have to access, the firewall will allow their traffic to pass through. Remember, these guys try to access instant messaging like what, Skype, what those things, then the firewall will automatically go ahead and block them. So configuring a security zone on a web user interface. We looked at this firewall, and we'll share with you a detailed video on how you can also configure yours on your desktop, but basically you just go to network and you go to zone and you add the zone list, and then you add the different zone parameters. Let me see if I can start ENSP. Okay, as ENSP is starting, so you just go click on zone, click on add, and put there your parameters, and then boom, you have set your zones on the network. So you have our ENSP. I did not save the last topology, so I'll have to go ahead and create it again. Have my firewall here. Okay, have my firewall. I can choose to connect it through a switch, and then come to my cloud here, change the port to gigabit Ethernet, my ENSP adapter, go ahead and add it, go ahead and add UDP, go ahead and change gigabit Ethernet here, go ahead and add that, then add that there, then close, come here, copper cable, connect to the switch, port 1 and the switch, then connect it to my firewall gigabit Ethernet. That, then come and power on these devices, and they take some time to load, but as they're loading, okay, take some time to start. It will hash like forever, but as it's hashing, we shall be continuing with the lecture slides. You can go to network, go to zone, and then go ahead and add the zone. So this material will be shared with you. So kindly just go ahead and look through that material and try to play with some of those things in your free time. Security policies, you can, set matching policies, just like you see here, to see the matching policies, the default policies. So a matching condition, security zone, destination security zone, those things that you're seeing there. And then source address, and then that action, you can either choose to permit or to deny. And the content security profile, that is the antivirus, and it's usually always optional. You can choose to also have that. So to add also addresses and groups of addresses, still you go to object, and then you go to addresses, and then you go to add, and then you add your pool of addresses. An address object is a set of IPv4 or IPv6 addresses or MAC addresses, and the address group is set of address objects. An address object contains one or more IPv4 addresses or MAC addresses, and it's like a basic component that can be referenced by different policies. So we have our firewall, which has successfully booted up, thank God. And we said what was our default username? Anyone who remembers?
Admin.
Small admin. Yes.
Admin. The default password?
Admin at 123.
Admin at 113.
Uppercase.
Admin at
letter A.
Up to A.
Admin we changed it to way.
No, we have not.
H.
Remember, this is a new. Please, if you have noise in the background, mute. Listen to your environment. If you have noise, mute. And maybe just try and contribute in the chat, because now we can't hear from each other.
This is new to me. I haven't seen this lecture before. I don't know. I'm not sure which one it was.
Then just go back and read the material because you missed that lecture. So we said it is admin at 123, and then we hit enter.
No.
And then we hit.
It was changed to Huawei 1.
No, that was another topology. Remember, this is a new topology. It's a new machine which I've just created, right?
Oh.
The other one was yesterday. This is a new environment, right? I did not save it. That's why I had to. If I had saved it, I wouldn't even wait, have to wait and, waste time trying to do all those things. So now it's asking me to enter old password. We said it is admin at 123, and then I enter new password. I'm going to change it to Huawei at 123, and then I'm going to repeat it, Huawei at 123, and hit enter, and I've entered into my firewall. But now I need to configure, since I want to access it via the web browser, I need to configure it. Remember what we did when we wanted to configure it? We need to enter system view, right? And if you see square brackets, you have entered system view. Now we want to enter the interface where we want to configure and permit that kind of traffic to flow, right? So I'm going to enter interface, which is the management interface, the one we talked about. Yes, I think it was yesterday.
Gigabit Ethernet 000.
Okay, gigabit Ethernet 000 is our management interface, and boom, I've entered into my management interface, and I'm going to enable service manage, right? So I'm going to say service manage, enable, and I've enabled it. And now I need to permit, which protocol do I need to permit? HTTPS. So I'm going to say service manage HTTPS. Do what? Permit. Isn't it? I go ahead, I've enabled HTTPS. So I'll come to my web browser. And in my web browser, we said what is the default IP address for the firewall?
192.168.0.1.
Going to use that port number because it's a layer 4 device. The default port is 8484. It's going to ask us
HTTPS.
Yes, it's HTTPS. The connection is not private, but we know it's private because it's within our computer. And then we are going to say continue, and boom, we are in, I am in our firewall. Now the default username is admin, and the default password, the password we have changed to is Huawei at 123.
Huawei at 123.
So I'll put it in and hit enter and wait for it. I don't know why it's taking forever. Okay, as it's loading, that is how you access the firewall. All right, so as it's loading, so you just go through those things. It will load, have a graphical interface. You can just go, basically they're straightforward, and how you can be able to configure and set them up and configure security policies on a web browser. You just follow those details and you'll be able to access those things. So security policy configuration, you go to start security policy zones, configure the interfaces, determine the user and authentication, configure the objects, create profiles. Basically, they're just showing you the procedure, how you can be able to configure security policies on Huawei firewalls. If you are in command prompt and you want to configure it using command prompt, you can as well as configure if you either access using either console port, or you go ahead and access either SSH and you're in the console for the firewall, like this firewall here, you can go ahead and pass on some of those commands, like this command, and say security policy, policy, and then you hit enter, and then command not found. Oh, wait, I had to make sure that I go back from.
There's no I.
Forgot a Y on security.
Forgot a Y, yes. And also I was in an interface port. So I go to system view, and then after going back to system view, now I type in security policy. security policy, and then hit enter. Oh, I always type the word wrongly.
You have again forgotten the E.
Creed.
I noticed, yes. So you again enter into a security policy, and then you give it a security rule name, blah, 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 and you continue. And you can follow these procedures just to, play with them and, make yourself well conversant with the IP address. So you can configure that to allow blah, 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 depending on what you need to achieve. So let us look at the policy that is called the ASPF. The ASPF.
Sir, does the Huawei gadgets also have initials? For example, the way we do with Cisco routers, like for example, if you want to enable a device, you just type EN. Does Huawei have such parameters also?
Yes, it has. For example, if I go back here to the system view and I say, if I want to say display, right? Display interface brief. As you can see, I've used initials, right?
Yes.
I don't have to type the entire word. I've used just initials, and it has displayed for us the interface brief, that these are the interfaces that are up. If I wanted to display IP interface brief, I would also still use the initials. As you can notice, I've even not finished the word interface. I've just write NI, right? Here, display IP interface brief, and it has displayed for me the interface brief that this interface 001 is assigned with this IP address of 192.168.00.1, and it is up and running. Okay, so let us look at ASPF, and we are saying that multimedia application protocols such as FTP and others like SIP prescribed ports to initiate a control connection, and they then dynamically select a port for data transmission. Dynamic is a keyword. So port selection is unpredictable sometimes, and that's why this kind of application is hard for us to, to apply when using packet filtering firewalls that rely on access control lists, which are static in nature, to match the applications of single channel protocols to prevent network attacks. Because now access control lists can block only application using fixed ports that our challenge arises. If the protocol, some of them are going to use dynamic ports, how are we going to be able to effectively make sure that we can either block or permit such kinds of application on our network? That's why we come up with something we're calling a multi-channel protocol applications that use random ports to bring security, to bring security risks. So multi-channel protocol technology, single channel protocol use only one port during communication. For example, HTTPS uses port 80, whereas multi-channel protocol uses either 2 or more ports for communication. For example, FTP uses passive mode uses port 21 and a random port to also assign a random port at the end. So only how to use packet filtering methods to precisely determine the ports used by multi-channel protocols. It is a challenge, and that's why we want to look at some of these protocols that are going to help us get rid of that challenge, that the ASPF. Now, the ASPF is what you're calling the application specific packet filter. ASPF, application specific packet filter. It is an advanced filtering technology, and it checks application layer protocol information and monitors the status of the connected application layer protocol. Now, for all communications of a specific application protocol, the ASPF maintains status information and dynamically determines whether to permit the data packets to pass through the firewall or discard the firewall. So it looks mainly at the status information that it's going to maintain, and then it dynamically determines whether to permit or deny or discard the packets. So ASPF is used to filter packets at application layer level. And just like you can see, we have our packets, it's coming through. We have a control channel and our data channel. So the data channel is dynamically negotiated by control packets, and to prevent the data channel from being disconnected by other rules such as ACL, a channel must be temporarily enabled. and that is when this multi-channel comes up with something which you're calling a server map. So for example, this user uses port 4952 to set up a data channel connection with user 2, and it creates some kind of random port number to be able to determine that. So the generation of server map entries because now this comes up and it generates server map entries, and the server map entry is generated during the dynamic detection of the FTP control channel. So when the packet is passing through the firewall, the ASP is going to compare the packet with a specified access rules, and if these rules permit the packet, then it's going to check, and otherwise if they are not permitted, then the packet will be discarded. So it's going to look at those things, but in the process, server map entries are going to be generated accordingly. And server map is a mapping relationship. Basically, when I talk of server map, it's a mapping relationship, and it's going to just match dynamic server map entries. The firewall does not need to search each of the different, packet filtering policy. And this mechanism just ensures that normal forwarding of some special applications that uses dynamic or multi-channel protocols can also be effectively looked up, thus getting rid of the security risk which we have. So the server map is used for only checking the first packet, and after the connection is established, then packets are forwarded based on the session table. We talked about that, and we said previously that is what we can refer to as stateful inspection. So let us look at generation of server map. Currently, the firewall generates server map entries in the following situations, okay? And we want to look at them. We are saying server map entries can be generated when the firewall forwards traffic from multi-channel protocols such as FTP, RTSP, and after this ASPF has been configured. So server map entries can be generated, just rephrase, when you configure ASPF and the firewall forwards traffic of multi-channel protocols such as FTP and RTSP, and then the ASPF is configured. Another option here, static server map entries can be generated when NAT server mapping is configured. It can be generated when NAT server mapping is configured. Also, triplet server map entries can be generated when the firewall forwards traffic using the simple traversal of UTP through NAT protocols such as SMNS, TFTP after ASPF is configured. The keyword to note out of this is after ASPF is configured. And dynamic server map entries can be generated when NAT no part is configured. That is the generation of server map entries. So support of multi-channel protocols by port identification. We can use port identification maps or non-standard protocols to identify identifiable application protocols. And we can add them, for example, ACL 2000, and they can go all the way to 2009, 2099. So we can also use those ports to be able to identify. We have host A here with IP address 10.0.0.1. And remember, we said that data channel will be generated, and then the control plane also be, and then in the process, server map entries are generated. So what is the application protocol for port 31? I don't know. Then it will go and look at the different map entries which are generated. Then you can configure port 31 and you give it the access control list of 2000. So the fragment check function is used to catch fragments. The fragment catch function is used to catch fragments that arrive before the first fragment is in the flow. This function prevents the firewall from discarding packets. Imagine if you have sent packets and they have gone, but before the first packet reaches, subsequent packets first reach the firewall before the first packet. So this fragment check is going to first catch them. Fragment catch is going to first catch them and store them before it arrives to prevent the firewall from discarding these packets. And when this guy arrives and they do the first packet processing and they check our security policies and they permit it or deny it, then also the subsequent packets, depending on the session header or the session status, they will be also processed accordingly. So until when the first fragment reaches, this guy will go ahead and store the can catch the other packets. Usually the first fragment has a tag of 001 and the subsequent packets have a tag of 000. So they'll be able to fragment them accordingly. Persistent connection. Persistent connection is important because sometimes you have aging mechanism of the firewall in the session table, and problems may be caused by session aging mechanism for special services. The aging mechanism is put in place that in case we don't hear from this guy for this time, it is pointless for us to keep the connection open for long, because if we keep them open for long, we shall be wasting our company resources. So what we do, we can come up with some kind of aging mechanism to make sure that we stop the session. And if no data is transmitted within the session aging time, then the session will be automatically closed. So if the interval of two consecutive packets reaching the firewall in the session layer, in this case, after subsequent packets reach the firewall discards the packets. As a result, the connection is interrupted. Imagine for some reason or another, you're trying to access LMS.send.es to do the assignment, but then because of network connection or issues, your packets take long. Your ISP first goes some time, but you had established a connection with the server. Aine, I'm going to remove okay. And for some reason or another, then the session is disconnected and all your work, or imagine you are in the process of banking. So that's why we come up with a persistent connection to make sure that when that comes, some of these connections are not terminated. So firewalls support the persistent connection function only for TCP packets. And when stateful inspection is disabled, the firewall also creates session entries for non-fast packets. So in this case, you do not need to enable the persistent connection firewall. So basically, this is to help us solve this problem, and the firewall will just help us to configure the persistent connection in those zones that we have permitted them to configure. And you can also set a long aging time for the sessions of the packets that match the ACLs to ensure that no more use of sessions are taking place. But the default aging time of persistent connection is usually 168 hours. So which of the following situations will server map entries be generated? Let me put up a poll. Let me disable chats and put up a poll and say which of the following okay, did I put the other question? Okay, question one, which of the following situation where server map entries be generated? That's question one. And question two says a firewall has 4 default zones and the security zone levels of the zones cannot be changed, true or false? The questions are on your screen. The questions are on your screen.
I can't see the poll, Mr.
The
Cindy.
poll has disappeared, sir.
Mr. Cindy, the poll has disappeared.
Disappeared.
Please do it again. One of my co-hosts has ended it, but kindly poll it again. Please, co-hosts, do not just click anyhow. I'm sorry, co-hosts, you cannot take part of the poll because you are now co-hosting this meeting. All right, you have about 20 seconds. You have about 10 seconds. Okay, I'll end the poll and display the results to you now. That is what you have selected. About 41% said, about 32% said A, and 57% said B, together with C, and together with D. Now let us first look at the first one. I said, which of the following is a situation, in which of the following situations will the server map entries be generated? And I think one of the last slides was talking about generation of server map entries, right? And I think I mentioned them pretty very well. And I said, server map entries are generated when the firewall forwards traffic of multi-channel protocol, such as FTP, after ASPF is configured. I even highlighted it. I said static map server map entries can be generated when NAT server mapping is configured. I also highlighted it, isn't it? And I said it can also be configured when traffic, when the firewall forwards traffic of the simple traversal UDP through the NAT protocol, such as SMS, after when ASPF is configured. I highlighted it. And I said dynamic server map entries is generated when NAT no part is configured, right? NAT no part. So go back to the question. The people who are selecting this, I don't know where you got this because I don't remember talking about it. Did I? I talked about NAT no part, talked about server map entries is configured, when NAT server map entries is configured. I talked about when also ASPF is configured. I talked about these three. This, I don't remember talking about it, isn't it? So this makes the answers to that question correctly. So let us look at firewall. Question 2, a firewall has 4 security zones. Default security zones, that is extremely true. And the security zone levels cannot be changed. And that is also true. I could have not mentioned it, but I want to mention it now. I think I forgot to mention it. But the security zone levels cannot be changed. Okay. All right. So that brings us to the end of this lecture for today, and I'm also going to end today's lectures here today. And I'm going to